These are unequally yoked. So what I do is I just split off the first two here. So this sum, what are the first two things in it? The n equals, so I'll write down n equals 2 and n equals 3, right? Those are j equals 1 and j equals 2. Excuse me, j equals, I can't do math. J equals 2 and j equals, no. J equals 0, j equals 1. Thank you. Good grief. What's wrong with me? So many things. Let's see here. 2 times, that's a sub 2? Yeah? Right? 2 times, oh, I'm sorry. 2a sub 2, right? Plug in 2 here. 2a sub 2. How about what happens when I get to n equals 3? I get 6 a sub 3 what? 3 minus 2x. Now, I can write down the sums together. So sum j equals 2 to infinity of this stuff, which was what? This is actually j plus 2 times j plus 1 times a sub what? j plus 2 and then minus a sub j minus 2, right? And yep, all times x to the power j. And this is equal to 0. Yeah.
Because we said in one case j equals n minus 2, in the other one j equals n plus 2, those j's aren't equivalent. So how can we combine them later? Or am I missing?
I could put an in-between step, call this one k, and then I'd have sum over j, sum over k, and then I would change the k to a j, and then add them.
But like they're just we just picked arbitrary like differences between
No.
n and j.
I did not. I said j is n minus 2 here. J is n plus 2 over here. I'm not applying both of these rules to the same expression. I'm applying them to separate expressions. If you want me to, if it's helpful, this will give me sum j equals 0 to infinity, j plus 2, j plus 1, a sub j plus 2, x to the power j. Then over here, we get the sum j equals 2 to infinity, a sub j minus 2, x to the power j. J is a dummy index of summation. You could take both of these and relabel them something stupid. Let's see here. I'll do the stupid one over here. Like I could put star. It wouldn't be any different mathematically.
But then because those wouldn't have the same thing above, it doesn't matter that they're different.
So the point is, I have to make both sums both have the same starting point. Once they have the same starting point and the same sort of monomial next to the coefficients, then I can add them. Now, if I had like, well, anyway.
I see that.
So I could put an in-between step where I use not j for both ones, but it's just a lot of extra writing, and once you understand what we're doing, it's not, I think this isn't too bad. There are other people who just relabel n. They do something like n minus 2 goes to n. No, I will not do this to you. But there are people who insist on calculating in that fashion. I cannot do that. So I just use j as an in-between. Now once I'm done with that, if I don't like the way my j looks on a particular day, I'll convert it back. I mean, this actually says, if you want to, I mean, directly it says that this in terms of j is 0, but let's use n because it's easier to look at. my n's are neater, n plus 2 times n plus 1 times a sub n plus 2 minus a sub n minus 2 is equal to 0. For what n? I mean, I could write it down with j's originally. I mean, that's what I usually do. But this would be for j greater than or equal to 2. Since I changed the j to an n, this is for n greater than or equal to 2. What else do we get from this expression? This is the thing sometimes you guys ignore, but you shouldn't, because these are the most fun and easy part. These guys over here. This tells me that a2 is 0. And that tells me that a3 is 0. Those are actually kind of important. Because
you don't know what you're getting.
if they're not 0, you might trick yourself into thinking that there are 4 linearly independent solutions to this problem. But guess what? This is a second order differential equation, so we're still looking for 2 linearly independent fundamental solutions. That's still here. So now, what we do is study that recursion relation. So let's see here. Let's write it down nicely. So I like to write that as an plus 2 well, I'll write it down this way to start with. An plus 2 is equal to a sub n minus 2 over what is it? And n plus 2 times n plus 1, right? But this is too much thinking. Let's switch it up a little bit here. This we could rewrite as, let's say, a sub k maybe equals what? K plus 4, right? K times k minus 1, right? What did I do? I put k equal to n plus 2, right?
Should that be a k minus?
Didn't I write k minus 1?
I mean, on the top side. K minus should be k minus 1.
These match. And then this is 1 less than that. What do you mean this side? This side isn't for up for grabs.
So I mean the top side, the k, ak plus 4. Should that be ak minus 4?
Oh, now that's a good question. Yeah, thank you. Let me check on the, okay, fine. Now you've convinced me I need to check. So k equals n plus 2, right? That would say that k minus 4 equals to n minus 2. Very good. Yeah, you're right. Thank you. That is very helpful, because I was about to waste a lot of time. Yeah. Oh man, no, that's not how I want it. Oh, stink. Oh, man. It's not wrong, it's just not right. Just a second here. Let's try this again. I want to solve for n minus 2 equal to n plus 2 times n plus 1 a sub n, n plus 2 like that. Please tell me I haven't made another silly transcription mistake here. Well, no, it's fine. I'm sorry. I'm just being dumb here. It's fine. It's fine. I guess I just made the wrong substitution. So if you don't mind, I will substitute yet again. Eventually I'll get to the one I want. How about this? N plus 4 is equal to a sub n divided by what? This is what I wanted. I'm sorry, guys. I just have, this is the part of class where I start to lose what modicum of common sense I came here with. So there we go. This is the one that's easiest to think about. So let's play. So a sub 4 is equal to a sub 0 over 4 times 3, right? Which, of course, all right, what's a sub 8? A sub 4 over 8 times 7, right? Which, by the way, is a sub 0 over 8 times 7 times 4 times 3. What's a sub 12? Right? What's the general pattern here? A sub, let's see here, 4k, yeah? We get a sub 4k minus 4 over 4k minus 4 times 4k minus 3, right? Which is, by the way, equal to a sub 0 over 4k minus 4 times 4k minus 3, times 12 times 11 times 8 times 7 times 4 times 3. You could clean that up further by gathering even powers. All right, I'm a little short on time, so I won't do that. But this could be cleaned up a little bit more. How about 4k? How about 5? What's a sub 5 equal to? A sub 1 over 5 times 4, right? What's a sub 9 equal to? A sub what? A sub 5 divided by 9 times 8, yeah? Which, by the way, is a sub 1 over 9 times 8 times 5 times 4. You see where we're going with this? A sub 4k plus 1 is equal to a sub 4k. I'm sorry, what did I do right here? Yeah, a sub 4k minus 3. Let's see here. I'm supposed to subtract 4, right? So plus 1 minus 4 is minus 3, right? So we got 4k plus 1 down here times 4k, right? Which is going to be a1 over 4k plus 1 times 4k, 9 times 8 times 5 times 4. There's what your arbitrary coefficient looks like. You can follow the pattern, go as far out as you want. Now, how about what happens when we get to, what about A6? What about A7? A6 is what? It is A2 over 6 times 5. A7 is A what? 3 over 7 times 6. What's that equal to? 0, right? And by the way, a sub 4k plus 2 is equal to 0, and a sub 4k plus 3 is equal to 0 for all k, by very similar arguments to the one I gave you, because there's this fourplicity that they're connected by, by 4. If 2 is 0, that makes 6 and 10, 14, 18, and on up the line 0. And likewise, the fact that 7 is 0 makes 11 0, makes 15 0, makes 19 0, makes 23 0, and so forth and so on. So what's the general solution? all you got to do, I've erased it, is y equals to the sum, k equals 0 to infinity, of a sub 0 over star, let's see here, x to the 4k, plus a sub 1 over Pac-Man of x to the 4k plus 1, where this right here I'm calling star, and this right here I'm calling Pac-Man, in the interest of us actually getting to leave this room. Okay. So. Sorry to go a little bit fast at the end. I wanted to go really slow at the start of this calculation to make sure you understood what I was doing. It's simple, but you have to be methodical and careful. You should not hurry these. If you're going to hurry one of these problems, just don't even bother doing it. It's not worth your time, right? Yeah. I described all math right there.